My name is Michael Bean. I work for Dredge and Dock. I am the Director of Production Engineering and R&D. So I've been with Great Lakes for about 13 years. Started my career over in the Middle East. I worked in the Middle East, in Africa, South America, worked in the United States, and about 2016, I joined head office, and I've been working in the engineering design side of dredging, working on physics calculations, model creation, helping to build our projects from an engineering standpoint. So my department works at we receive bid documents from the government or from private clients, and my group basically takes that information and creates a plan for how we're going to execute a project. We look at the soils, and that goes to cost, and then we bid projects. And then if we're lucky enough to win a project, we then go ahead and follow and track that project, optimizing, improving, and making decisions to improve the project performance and solve issues in order to make sure we stay on schedule. So today I'm going to give a presentation on what is dredging, the basics of Dredging 101, cover a little bit of all the different fleet types that we have, the history of dredging, and then we're going to lead on a little bit into some pictures about my early career and different action shots that we've taken over about the first 6 or 7 years of my career when I spent most of the time out on the actual vessels. So let's get started. So Dredging 101, the basics. So what is dredging? So early dredges, and people have been dredging for thousands of years, but dredging is basically as a vessel outfitted with equipment needed to excavate underwater materials. So people have been dredging for thousands of years, as I've said, but the Dutch invented the bag and spoon, which you see in the top left. It's a bag at the end of a pole. And in about the late 1800s, the first suction cutter dredges came along with the Industrial Revolution that really made production much, much higher. So even when the Egyptians were dealing with the Nile and they were cutting paths for water and making sure the Nile was good for irrigation purposes, that's dredging. A nice little tip of information is this picture in the bottom left has 4 people on it. That equals about 1 horsepower. And in today's world, we're dealing with dredges with 25, 30, 35,000 horsepower. So significantly increase in productivity and power of our modern equipment over the last few hundred years. So there's 3 basic operations to dredging. First of all, we have to cut or disturb the material in the water. So that's at the seabed. We transport that material to the surface. And then once we get it at the surface, there's many different ways to transport that to a disposal location. And that could be a beach, that could be an offshore dump area. It could also be taken up and unloaded for beneficial use. So there's many different ways that we use the dredge material. So dredges typically get classified based on how they perform these functions. So at Great Lakes Dredge and Dock, we classify our equipment into 3 categories: mechanical dredges, i.e. clamshells, backhoes, and dippers. We don't currently own any dippers. We did many, many years ago. And backhoes, you can think of it as sort of like your excavator you see on a normal construction site. Then we have hydraulic dredges. So these we call cutter suction dredges. They cut the material at the seabed. They then use pumps to bring it to the surface, and then they hydraulically push that down a pipeline to a disposal location or into a scow. And then we have hopper dredges. So this is a completely self-dependent vessel. It goes to a borrow area or a sand source, digs the material up using drag heads for cutting, and then through pumps for hydraulic to transport it to the surface. Load it on like you'd expect a normal vessel. The material gets dried through overflow, and then we sail that to a disposal location. And I'll show you pictures of these in a little more detail as we move along. So disturbing the material. So there's a number of different ways we can do that, right? We can do that by pre-treat. We can blast material. That's one way we deal with very hard rock. We've done that in the past by rotating a cutter head. So that's why I said the CSD rotates a cutter head, and I have pictures to show you guys. Teeth dragging. So that's a drag head is an instrument for cutting the material in a hopper dredge. It's dragged along the sea floor. Think of a vacuum in reverse. A bucket dredge, which is then, like I said, like an excavator on a construction site. And then there's a few other little things. We can use water jet erosion in the teeth of a drag head or on a water injection dredge. You can use that to kind of disturb and break the material, or through erosion of that process as well. So once the material gets to the surface, and I swear there's pictures in this presentation, once you get to the material to the surface, it must be moved to its disposal location. So we often do that with a slurry of material. So that's a mixture of soil and water through suction pipe. And sometimes we can also do that by lifting it mechanically with our excavator, literally just scooping it off of the seafloor, or off of the seabed or sand source. Once at the surface, it gets moved to the disposal site again by either pumping it hydraulically along a long line, put into a hopper bin or a scow and taken somewhere, or a combination of two depending on the type of project and material that we're using. So these are the types of dredges that we operate in. So remember I said mechanical, cutter, and hopper. So let's first look at a clamshell dredge. This is mechanical. And as you can see there, on the left-hand side, we have a dredge dropping a large bucket. These buckets can range anywhere from about 12 cubic yards to 50, 60 cubic yards in size, depending on the vessel. And they go to the seabed. They drop, they use their natural weight to penetrate into the material, and then they close. And as they close, they pick up the material and it's hoisted back up. The crane hoists it back up to the surface, and that crane rotates around a point, which allows it to swing the material into a barge. So these are very quick to set up machines. They don't require an awful lot of support equipment. They're very good for turbidity, for environmental reasons. They're probably the least expensive type of dredging operation. Poor performance in hard material because you're reliant on the weight of the bucket. And then they're very good at transporting long distances because we load into scows and then we send the scows away, sail the scows away, and you can sail them for as long as you like. Very good at digging soft material because it's bucket weight, and good at multiple digging depths because you're only limited by the length of your wire. So here's a picture of our Dredge 54, which is one of Great Lakes' larger clamshell dredges. You can see there the crane, you can see the bucket, and you can see the bucket just breaking the water as it drops into the water, and they'll rotate, pick that up, close it, lift it, and put the material in the scow sitting on the left. And you can even see a crew boat in the back sitting alongside the dredge, which was where we transport engineers and staff back and forth from the vessels. So this type of dredge has been used for a very long time. Great Lakes has been around for over 135 years. So we have a long history of dealing with these kind of vessels. Today, we talk about buckets in the, like I said, in the 10 all the way up to 50, 60. This bucket's probably only a couple cubic yards, if that. And here is a 1927 picture of a derrick. We call this a derrick B5, probably somewhere in the Great Lakes itself. Here's another one, the 47 from 1927. Again, this is probably steam powered by the looks of it on the back, and a very small bucket. And rather the whole of the clamshell rotating completely around a point, this one is just moving the actual arm left and right. Then we move on to backhoes and dipper dredges. We see the Dredge New York in the top left, and that's the one I said was very much like a excavator that you see on a normal construction site. So that uses positive force and pushes its arm into the material to scoop it up. And then we have the dipper dredge in the bottom, which is the other way. It uses positive force to pull the material from under up. So very few sport vessels needed for these, again, but they're limited by dig depth because the arm dimension determines how deep they can go. They have lower capacity at depth because the further down we go, the more extended the arm becomes, the less weight they can use. They're very good for positive force, as I said, scooping. They're good for digging clay materials, hard materials, blasted rock, or large-sized boulders that need to be removed. So this is the Dredge New York sitting on one of its projects. You can see the scow in the background. So, and again, this is a dipper dredge. This is a 4 cubic yard bucket in comparison to the 26 plus cubic yard buckets we use on them today, and digging material in a river somewhere. I'm not sure where that picture was taken. And you'll often hear in dredging, we call things that our control rooms are lever rooms. Today, our rooms are joysticks, digital screens, and touch panels. But back in the day, a lever room really was pulling levers. So this is a nice picture of that. So that moves us on to our second type of vessel, which is the trail and suction hopper dredges. These are self-contained vessels. They don't require any attendant plant hardly ever. They dig very good for digging loose material. They can agitate very soft material, and they can potentially lead to higher turbidity, but it depends on the material type that you're digging. Most effective when long distance from disposal site because they can load and then sail to a site. Material is soft and fine. They're very good at sorting that material out, and then digging offshore in rough conditions. So sometimes when we dig in a bar area, we can have 6, 7, 8 foot seas. These dredges can continue to operate, where other dredges would have to go to dock to get out of the weather. So our little dredges, our Manhattan class dredges, are split hulls. So the ship literally splits down the middle, so they can open up to dump their material. So that you can see that in a second. But here's one of it loading, and then here's it unloading when it bottom dumps the material. We also pump the material out. So what happens is the material is loaded in by a slurry, and you can see that slurry. And as the material goes in, the heavier particles of the slurry settle out. So the sand settles in the hopper and continues to build until you get something that looks like what looks like on the right. And all of the water gets overflowed. Then we go to our dump site. This is splitting. We go to our pump out site and we reintroduce water by jets and turn the material that was a slurry that we turn into a solid sand back into a slurry. And then we pump that out directly down pipelines like the top right by rainbowing overseas in the past, the bottom left. And you can see it comes back out as a slurry on the beach. Again, the process repeats itself where the coarse sand settles out and builds the beach or disposal area, and the water gets washed away. So this is our current fleet, or was our current fleet. We don't have the Terp anymore, but the Liberty, Dodge, and Padre. We also have the Ellis Island. I don't have a picture of it, but we also have the Galveston Island. They'll be joining the fleet later this year. So quite a large hopper fleet. And just for a size comparison between these, you can see on here a number of containers, and you can 40-foot containers, and you can see how large this vessel is. It's over 400 foot long, and it carries about, you can carry over 12,000 cubic yards of sand. So that's quite a large load size. And that brings us on to cutter suction dredges. So you'll see the pictures of the cutter suction dredge on the left, and you can see on the bottom they have a very large cutting instrument. This really is for the hardest of material. They require a lot of attendant plant. They're very expensive to run. They're very large vessels. They have high turbidity potential in certain materials, but not very high in a lot of materials. They're very flexible because you can do everything from the very soft to the very hardest rock with them. And they're very good at short and medium distance because they have to hydraulically pump the material down a pipeline, but they can dig pretty much everything. We've dug everything from muddy water all the way up to very hard, dense rock. So this is a side profile to give a better idea of what we're dealing with. We have a ladder that lowers into the water, and on that ladder there is a rotating cutter head that digs the material and scoops the material up into a vortex. And then we have an underwater pump that provides a suction to drag that material up through the system into large main pumps. And when we talk about main pumps, we're talking about, pumps that can be 108 inches in height, huge big pumps, so that they're taller than most people by a long shot. Even the underwater pump is as tall as I am at 6 foot. So that ends up being pulled through and put potential energy into it, and then we pump it down the line. So this is our little Dredge Alaska. So we say little, but she's 300 foot long. And this is the larger Texas, which you can see a much more robust structure for rock digging and heavier material digging. So we also have a number of specialized equipment that we utilize for different projects. We have barges with drills and for blasting. So we go along, and on the top left you can see that each one of those is a drill rig. And they basically lower the drill. They drill into the rock. They're then able to put blasting down and blast rock into fractured rock. You can see in the top left what fractured rock looks like on the previous slide. So we blast that rock up, and then we go and we mechanically remove it. Can be very expensive, and there's a lot of restrictions about where you can blast, how big a blast you can have, for environmental reasons and to protect animals, environment, sensitive areas, old docks, things like that. So we have to be very careful about that. And then we have pre-treatment. Once it's pre-treated, remove it with mechanical or cutting means. Then for material, you've heard me say scour quite a lot at lots of different areas. So material barges or split hull hoppers or deck barges, you can see one on the left is a split hull. So we put all our material in it, we sail it to our disposal, we split it open, the material leaves. It's good for long distances. Job sites or disposal sites may have limitations on draft and height. You can see the draft markings on the left-hand side of the vessel there in the white numbers down the side. So we're always checking how much material we can put in before we get to a limitation on how deep we can be in the water. Most of these are unpowered. require a tug to move them around. And then on the bottom left, we also have a booster pump. We have a number of different boosters in our fleet. So when we're pumping out with hoppers or with cutter dredges and we're putting energy, pumping material down the line, we lose energy through friction and friction losses and angles. And we lose as we lose that, we need to reinstill more energy into the system. So we basically use additional booster pumps to basically infuse more energy, put more potential into the system. So here's a couple looks at projects and cool pictures I've taken over the years on earlier projects. So when I started my career back in 2010, fall of 2010, I worked in the Middle East. So here's some early pictures of dredges actually rainbowing this reclamation. We would come in under shallow areas and we would bottom dump up to a very shallow depth, and then we would rainbow in over top of it. And this total project was about 80 million cubic yards. So you can think about the sheer amount of volume. You have to do a number of loads when one of these can hold about 2,500 cubic yards per load. So it really is a very large project.
So Michael, what exactly were the dredges doing here?
So what the dredges doing here is we're in the Middle East. They suffer from a lack of area to build on. So what they're doing is building artificial land in order to create housing and infrastructure support. So what these dredgers would do is they would sail off into the surrounding area up in the ocean. They would pull up suitable high angular sand for building land, and then they would sail in and they would throw this material about 50 meters in front of them on to basically build an island. Once the island gets big enough, they come in and they put armor rock all around the island. So basically to prevent erosion and loss of material using geotubing, and which is a fabric that doesn't allow sand to pass through. They place rock on top to protect the fabric, and then afterwards they'll construct on it. I have a slide later on, Patrick, where you can see this one from Google Earth with the building starting to be built on it. So that's does that answer the question? So
yeah, that definitely answered the question. Thank you.
So here is this one's on the bridge. So you can see here what I was talking about. On the left-hand side, you have the island being built with the rainbow, but you can see the vessel I was on board when I took the picture is actually split its hull open. So we're bottom dumping material across the front to fill in the area before we rainbow, because you can open and bottom dump in about 6 minutes, 7 minutes, but rainbowing could be pumping for an hour. So you need to be able. So this was the most efficient way of putting material into the compound. And then in the background, you can see a bunch of excavators behind a large berm. So that's where the berm's been pushed up. They're putting the rock armor in and other things, and they'll push the berm back into place or push the material back into place. Another picture coming in on a late night, doing more rainbowing. We have a sort of what it looks like inside the disposal, kind of all the different on board. This is the dredge from the other way. So we keep looking at everything from wheelhouse down, but this is the other way around. So now you can look at, I'm at the bow of the vessel looking back at the stern, and you can see that normally the operator is sitting up in the top, and right in the dead center of the wheelhouse there is a guy operating the 2 drag arms, moving the levers, picking all the gates, doing all of the pump work. And those pump out sequences are then analyzed by the engineers. We looked at suction pressures, drops in density across the pump out, and then recommendations and changes to methodology and sequence are done to keep improving and optimizing the production. So there's a lot of engineering involved. And then we also cross-reference that with the borrow area and sand sources so that we can find the most effective pumpable sand that loads at the best rate, and which cells were loading better, which sections are loading better, and where we are. So there's a constant 24/7 operation. And then their engineers are working all the time for optimization, having meetings on this all the time. So here's another type of operation we did. This project, we were pumping out about 6 kilometers. So 6 kilometers for 4-ish miles. So when you're piping that long, we can't hook these vessels up. It's too much work. So we dock them to a mothership scenario. And because we only had one location to hook them up, we would bring these vessels alongside, we would pump into the mothership, and she would relay the material to the disposal. And we had at one point 4 vessels simultaneously using the mothership, docking in. It was like being air traffic control. who leaves the dump zone, who's coming in for docking, who's leaving, who's digging longer, who's on standby, things like that. So getting that sequencing and running calculations real time. The person on board the mothership would have to calculate the most effective, what priority to give to which productive vessel first, and in order to take the least downtime with the other vessels and sequence it out. So that was quite a lot of work for whoever's on board. That was me that day, but yeah. Then when we were overseas, when I was early career, a lot of times we were digging overseas in the Middle East, we encountered something called cap rock. So overseas, we used to dig, there's a very fine layer of cemented sand and sandstone that lives on top of the sand, the good sand. So we would have to undermine it by breaking it up with a cutter head underneath, but in order to break that down. But I think this is a nice picture because it shows you the size of a person in relation to the size of the rock and the vessel and the cutter head. The cutter head's a 12 feet, 10 to 12 feet in size. We'd encounter different materials like clay. So we dig sand, clay, everything. So here we were using a rock cutter. We were digging rock and encountered clay. That's not a good mix. And you can see here how it's basically blocked up the entire cutter, which is very interesting. Here's us looking at different wear patterns on teeth. So something we're always looking at is each one of these teeth costs hundreds of dollars a tooth. So we're constantly looking at how we improve the life of the teeth so they last as long as possible. So we're looking at different patterns over there. That was me when I was much younger. So when I finished my stint in the Middle East over the first 5 years I spent over in the Middle East, I circled all the projects that I eventually was finished. So I was involved in DR al-Muharraq, I was involved in HID, I was involved in a couple more of these projects. And Patrick, to your earlier point, you can start seeing the housing structures go up in the north. So when we were rainbowing, that was on the very, very top island, the big one that circled at the very northern edge. So that was where we were finishing up the project. But yeah, you can kind of see all the different reclamations and islands being built over the years. I also did some time in Brazil. I didn't have a lot of pictures in Brazil, but sorry, one more. I also did a big island job in Qatar where we built all these islands in Qatar. So this is actually visible. You can view this pretty easily, but this is about a 10, 12 kilometer channel down the center for the docking of the new Coast Guard naval station there in Qatar. So we dredged all this rock. We took out 2 million cubic meters of rock here. So it was a big project. I spent a whole year of my life living on a camp or in the near a camp in the nearest town. It's about 2 hours north of Doha. And then I went to Brazil for a few months, or for about 6 months, and we were dealing with this pier on the right hand side, the one that's marked. And we were basically digging, it's harder to see, but we were digging an entrance channel to allow goods to be transported from this area up in the Rio Basin further off to other parts of Rio de Janeiro. So that was a good project. And that's all I have. Unless people have questions about what is dredging.
Okay. Let's see. So most of Adam, did you have any questions? If you do, just toss them in the chat. There you go.
The cutters are always super impressive to how they create. So the actual vessels, when we design vessels, we do a lot of design in-house, and then we use outside companies as well to work with for the design. In terms of the actual cutter heads themselves, there's a couple of companies that we work with to get them designed. We have recommendations of depths we want to use, teeth we want to use, size we want to use, blades, and then we use outside companies to talk with them on the design. And we have that relationship with them. And then in terms of designing how we work with them and where we put them, that's what my group does.
So what other than building islands, what other kinds of work does a dredging company do?
Yeah, so we do a diverse set of work. So my early career was spent building islands, right? But in the United States, we don't build islands as often. We do, but not as often. Not for Not the way that they use them for infrastructure like that. So over here, there's lots of things that we do. So we do a lot of maintenance work. So in ports and harbors and rivers, we do maintenance work, taking out soil that builds up or washes in or washes down into basins to make sure we have navigable depths into ports and harbors. We work to build beaches in terms of making sure that for recreation there's beaches and shore protection. So we do that. We also look at beneficial use. So we're always building new wetlands. We've had projects that have used it to build artificial islands for birds and habitat creation and things like that. So, well, the primary source of our and then the last thing that we do as well, one of the primary things that we're good at Great Lakes, is we do a lot of capital projects. So that's when we go in and we deepen a port or waterway beyond its maintenance level in order to allow for larger shipping, more ships, widening a project so that we can have more ships, capacity within ports. So I think that covers a lot of what we do, Patrick.
So we have a lot of engineers at Great Lakes. So disclosure for anybody that watches it, watches the video later. I also work for Great Lakes Dredging Dock. We have a lot of different kinds of engineers that come in with different kinds of backgrounds. How do you recruit, and what sorts of engineering skills and educational level and all of those sorts of things are
Yep.
you looking for when you bring in new engineers to work?
So we do have a lot of engineers. We've probably got close to 100 engineers between all the different disciplines. We have mechanical engineers, we have production engineers, we have site engineers and site staff. Most of our project management staff have engineering backgrounds. A lot of our executive group have engineering backgrounds. So when we look to bring engineers on board, we look to hire people. We're looking at graduates from colleges. We do recruitment directly with universities and directly with on college campus. We're looking for engineers with civil backgrounds, ocean engineering, mechanical. There's a few more that we take, but they're the main ones, and then but generally an engineering background. You can't go to school for dredging, so we have to teach a lot of people. So, but having backgrounds in civil and ocean gives you structural knowledge of soils and things like that that we look for. A typical career pathing is you have to start by learning from the bottom. You have to start by learning what we do as dredging. So not typical path is you normally come out of school, start with Great Lakes and start traveling up and down the country, doing projects all up and down the country, on the East Coast and in the Gulf. And after about a couple years doing that, you'll take more responsibility on the job site. At that point, you'll get to a fork in the road for career for engineers, and there might be opportunities to join pure engineering groups such as mechanical engineering, production engineering, cost estimating also takes engineers. But can they sort of geotechnical engineering is another one. Remote operation engineers we take. They all kind of come into the headquarters, and then some people decide they want to go into management, and they could become project managers and site managers and operations managers. That's kind of how we look at engineers. So the skill sets we look for is someone that doesn't mind traveling a lot, has to be a real problem solver, has to look to really get involved. We work in challenging environments sometimes, so we really need people to just don't mind working offshore, don't mind working on crew boats, don't mind working all times of the year, no matter the weather conditions, because we're outside all the time. We're always looking for problem solvers because we're dealing with a lot of unknowns in dredging. When we're dealing with digging different materials, we might end up with 2 boreholes in a bar area and the material doesn't behave like we expect it. So we need people around to look for solutions. I think that about covers it.
Well, so what are some of the engineering challenges? So we know that we have geotechnical challenges, like you just mentioned.
So there's one of the things we always joke about is production engineers are the first to know there's a problem because it first shows in production that the production went down. So some of the challenges that we do have is we have to work with the elements, we have to work with the weather, we have to work with the soils. Soils drive a lot of decision making that goes on. So when a production goes down, we have to look at the soils, and then we have to understand that. And then we have to try and model it using our internal software. And that can be challenging. You might have limited data set. Because we're working with job sites all over the country, we have to be very, very good at we have to be very good at working at solving problems in a remote way, right? So that brings its own challenges, whether it's phone calls, communication. Teams has been great, things like that, to solve problems. So I would say that is a big challenge too. And then because we're dealing with such large pieces of equipment, and because we're dealing with such a complex operation, sometimes you don't get an answer. It's not like you can't run a program or do something and say, hey, that's the solution. You got to come up with a plan, execute the plan for 24 hours, and then regroup. So that can be a challenge as well.
So what about kids coming out of a mechanical or electrical background who go into engineering because they like designing and building things? What sort of opportunities are there available for those people?
Yeah. So we have a mechanical engineering department that a lot of people that can join straight out of school, and those guys really work on designing the solutions for the problems. Um, in terms of working on vessel design, working on mechanical variations and modifications for safety and other things like that. So that's a direct hire into them. The electrical department is also hires directly. They do program engineers, system engineers, electrical engineers. So there's opportunities there. Those groups are a little smaller than operational engineers, kind of, and that means you really have to just watch out and look for an opening. Um, but those are the kind of opportunities in those field. And then we are always looking to in the IT pitch, which Patrick, we're always looking for new data architects and different people like that that can help bring us along in the technology space.
Okay. So you mentioned.
Bailey, I think
Go ahead.
Adam has a question. I'm curious as to what data has to work on. I heard there's a good bit of automation program behind it all, but we have to do so. We're in our digital sort of transformation, so more and more stuff is happening automated and by program. But you got to remember, so there's still someone goes to the dredge. They still look at the data. They still compile a recommendation, a report that gets distributed, and then that report gets absorbed by key people that can feed back and have a conversation. We still have to, but the dredge breaks up into a complete operation, right? So not only is there a person on the dredge, there's also a person on the survey boat doing echo, doing single beam and multi-beam soundings of the seabed to look at actual performance and then cross-checking the dredge performance against actual. We then also have a beach operation with dozers and movers and pipeline, and there's a whole operation there. And there's a report that goes out on beach progress issues, fill to pays, dig to pays, change in berm design, things like that that's going on in that. So there's like a multifaceted operation with many different components reporting up to project management structure. So, but on a day-to-day, I would say I'll break it out more into project phases. I think it makes more sense. But when the project starts, the engineer is very, very involved in making sure the dredge is set up, calibrated, and has engineering instructions about what to do, and that there's up backgrounds and screens and things like that. And that is a continual thing. Once we're in operation, it's very much about reporting, analyzing, and optimization of performance. And then at the very end, when we're finished doing, it's all about prepping the dredge for the next project and making sure all of the learnings get documented and put into the system for the next time. That's a good question, Adam.
So you mentioned pipelines,
Mhm.
and showed pictures of piping slurry through those pipes. What's the longest that Great Lakes has ever had to send that material to
About
dig?
don't quote me on this because I'll have to look at it, but I think it's 60,000. I think it's over 60,000 feet. It's definitely over 50. I might be close to 70. I'd have to double check, Patrick, but it's up there. Um, Several boosters, lots of power. I believe it was on somewhere in the Gulf we did that. So a lot of detailed calculations are done by the engineers. So we have a number of different pieces of software and programs that we use to make the calculations to check that. So a lot of design work goes in beforehand to make sure that those distances are achievable. There's enough power in the system that we can actually do it. And then we have to go and execute, and we check it, and we make sure that we're right.
So what's the most interesting project you've ever worked on?
I have a favorite project. I think it's the most interesting. There's a couple interesting projects, but the two I'll give you two answers. Just but my favorite one was that island project in Qatar. It was uh it was a pretty relatively new dredge. It only been retrofitted a couple of years ago. When that project was done, it was the first. It was one of the first times we really went after really hard rock with new cutter technology, and I really enjoyed being on that dredge every day, improving, optimizing. I wrote several reports on it in the end, and I really enjoyed that. I couldn't wait to get on the dredge, and I couldn't wait to get off the dredge. I couldn't wait to get on the dredge, and I couldn't stay out there long enough. I also built up a good rapport with the crew, and they let me operate the dredge a lot. So I used to actually dredge. I probably got 50 or 60 hours of dredging under my belt operating the vessel. And because we're with that crew for so long, we were with the same crew and the same group for 14 months. You build up a good rapport with them. You live next door to them. So they really let me crawl all over that dredge all the way into the pipes, into the hopper valve, all the way into the spud wells through the pipes. They let me hang around when they were changing engine oil and changing out pistons and power packs and pump jobs and everything. So they were really eager to show me everything they could, and it was a good experience. Um, so I think that has been my favorite project, probably my favorite field project I ever did.
So what are the biggest challenges today, right? The current challenges and whatnot. What would you say the biggest challenges are? And what challenges do you foresee coming up that that the future hires, the future engineers for Great Lakes will be focusing on?
So I think the biggest challenge for today is the rapid development of technology, right? Is that we all see buzzwords a lot. We say AI, we see automation, we see all these buzzwords, but what do they mean, right? Yes, to the average person, that's ChatGPT, or that is Midjourney, or Bing image generation, right? But what does machine learning mean to the industry? Is they sell it to the world as a button solve to everything, but it's not the case. It has to be targeted. So I think it's be very important that the people, companies, i.e., in engineering itself as a totality, and in Great Lakes, the way that we embrace it and where we point that, where we use it and how we use it, could have a big effect on the future of the company and where we go with it and things like that. Um, uh, that's kind of from a that's from a technology standpoint. I think that's what we want to keep it framed at, right, Patrick? It's technology. So
Anything
that's
STEM related, right? Technology,
yeah. So
engineering,
that from a actually
programming,
yeah.
any of
So
that kind of stuff, right?
So I think for me that's the other thing. And with this transition to cloud, I mean, it's early stages. So how quickly is that going to change, and how can you adapt and keep up with that change? So from a technology standpoint, that is probably a big change. Construction industry and in construction in general is typically not on the cutting edge of technology when it comes to that side. So embracing that thing is important. Well, that step is important. Um, and hopefully we get that piece right. What was the second part of the question, Patrick? It was challenges
Future
and
challenges for
future challenges.
future hires.
So for future hires, I think the world is moving more and more into this digital realm, right? So where an engineer before would have to grab a pen, an Excel sheet and work it all out in Excel, we're now getting more powerful and powerful programs. So I think anyone that has some code understanding of coding, some being able to read code, and more important than write code, but read code, do some, and embrace new tools and new ways of working, I think is how I would be as an engineer. When I started school, when I went to school, I just started C++ coding, and since then I've taught myself Python and other things. But the amount of benefit to that when I was being taught 12, 13 years ago um, was this might be useful one day. Now I almost see it's essential. So that's what my advice to new engineers, Patrick. Trying to learn some code.
Trying to think of another good question. So so based on some of the questions kids have asked and the others, uh, let's get a little more personal. What was your specific educational background, and how did that get you into dredging?
Oh, you want my intro story? Okay. So
Yeah.
my background is so I got a dual degree or 2 degrees, one in mathematics and one in civil structural environmental engineering. And I did both of those when I was 2010 I graduated. And Patrick, you'll know this, the kids will be too young, but in 2008 we had a pretty significant meltdown globally, right? And it wasn't a great time to graduate as an engineer in 2010. The market hadn't quite recovered and construction. So I actually had a neighbor a couple doors down who was in construction and actually was working in the Middle East and said, "Hey, guess what? Dredging is nonstop. It's booming in the Middle East." I said, "Well, thanks for the information. I never really thought I was going to get on a plane to the Middle East, but I decided to change tack, and instead of applying to the 80 other companies down the street from where I was, where I graduated in Ireland, I decided to apply to the American and Europe, Great Lakes and some of the European dredging and local dredging companies in the Middle East. And I was fortunate enough that Great Lakes saw that when they were hiring and offered me a 3 month summer trial. At the end of 3 months, they said I'd done a good job and could I stay, and I haven't looked back since. So I really owe it a little bit to the neighbor down the street that passed on some words of wisdom from just the fact that he was working in the construction industry in the Middle East at the time, that dredging was one of the least effective industries over there at the time. So I took a gamble. So 5 days after I sat my final exam, I was at the airport on a plane to Bahrain.
Nice.
So
Nice.
I was bit of luck, I think, that I decided to have a chat with my neighbor.
So, excuse me, if somebody watches this or when our kids go through it, somebody has an interest in dredging as a career, specifically engineering or programming or in the technical aspects of dredging, and wants to get into that. What would your advice be in terms of not just how to apply, but what to study? What are the most useful skills? College or self study or whatever. What would you suggest?
So I think the advice for dredging is probably similar to the advice of all engineering. I think if engineering is what you want to do, if you want to be a problem solver, you want to design new things, you want to build new things, which obviously this group do, it's the STEM group. My advice is really think about the engineering discipline you want to join, right? Not all engineering is the same. And I think that's something I really had to go through when I selected what type of engineer I wanted. My father happened to be a mechanical engineer at the time. And I think if you want to get involved in dredging or any industry within engineering, think about what it is, because we today in today's world, we have electrical engineers, mechanical engineers, production engineers, civil engineers, environmental engineers, geotechnical engineers. We have system engineers, we have, computer programming engineers. There's a whole plethora of engineers, right? But as engineering has become more and more technical and more programming specialization, you really have to think about what you want to do, right? So the reason I picked civil engineering is I didn't want to sit in an office. I sit in an office now, so that's ironic. But when I was 22, when I was 18 years old, I didn't want to sit in an office. So I said I wanted to go do environmental, civil, structural, something where I could go to a job site and build something. So I made a very legitimate choice to do that. And if you want to do dredging, then you really should look at civil, ocean engineering. You can do mechanical, but think about the construction piece. But if you don't want to, if you want to design nuts and bolts and screws and kind of structural, mechanical things like you know, you'll be a mechanical engineer. If you want to design electronics, you want to go design iPods, you could be an electrical engineer. And I think really understanding what you want to work with and the type of day in the life is going to be is really important, because not all the engineers are quite diverse. I happen to have two brothers that are computer programming engineers, and what they do is not, I know what I do is so different. I don't even know if you can call, they're both engineers, they're so different. That's a bit vague, Patrick. I mean, I think ocean and civil engineering are the best matches for what we do. Mechanical's pretty close too, but it's really important to know what you want to ultimately be involved in for when you pick your engineering degree.
No, I think that's great. I think that's very, very helpful.
Yeah.
Let's see. Adam, do you have any other questions? Or can you think of questions that uh, the other folks on the team should be asking?
Well, I'll add one more point, that if you do ever want to get into dredging and you start a degree in civil, environmental, whatever engineering you do, we do summer internships. So reach out and look for summer internships. We love people that come work for us and learn 2-3 summers in a row, have a better shot of working with us in the end.
That's a great point. I know that we get anywhere from 10 to 15 plus every summer, and sometimes during the winter break in between semesters. So
And there's
that's
many
great.
engineers that have worked here that said, well, I've worked here 3 years plus 4 summers. So that's some, or 3 summers. So it's really important to if you're really interested, reach out and do those summer programs, apply for them.
So what's your favorite thing about, well, I'll ask this in two ways. What's your favorite thing about what you do? And what's your favorite thing about dredging in general?
I'll do dredging first because that's easy. There's not many industries. I sum this up with picking when I said you have to pick the engineer you want to be, there's not many industries or types of engineering that I get to step foot onto a 400-foot long machine with 25,000 horsepower and break up 10 feet of rock. They're just not. It's just the size and the scale and the piece is why I like dredging, right? It's just cool, right? It's never appealed to me to design the nuts and bolts or design the handheld device of a hair dryer or whatever you do as a design engineer. I just never appealed to me. So the physical piece is what I love. I mean, I also love the outdoors. So the ability to get on a crew boat and ride in the ocean for an hour and then go to a boat and then dock on a vessel that's operating 20 miles offshore and all, it's just go to the beach and be putting up tens of thousands of cubic yards a day and seeing land be created. It's just a cool experience that you you may or may not get in other industries. I'll tell you the worst thing about my job and the best thing about my job, Patrick. That's probably a good way of doing it. The worst thing about my job or my position, or I think my group do, is we bid many, many projects. We don't win them all. And you can put your heart and soul into and hours upon hours and weeks on end in designing a project that ultimately we don't win. And that work gets shelved and archived. And I think that is one of the worst things about being a production engineer is not everything you work on sees the light of day, and not every project you work on you win. And it could be for no reason, anything to do with anything you did, and it normally isn't anything to do you did. It's a bidding market, and there's many considerations to bidding, but that I think is the worst thing coming up doing. The best thing about my job, I think I've worked myself into a position where I get to influence a lot of things. So not only the production, geotech, and other endeavors that I'm working on, I think my favorite thing is working on something such as an estimate or working on a project and then winning that project and seeing that project get executed. So um, I was the production engineer on some of the large capital deepening projects. Patrick, you don't know this from working with Great Lakes, but you wouldn't, that we've won in the past. And to physically know that you were the engineer that designed all the cuts and layouts and numbers for the deepening of a major port in the United States or multiple major ports is kind of probably one of my favorite things. Something that no one will ever know or anyone will ever really worry about, but I like it. Hopefully that answers it, Patrick.
Yes, I think so. Um, and I will add, yes, dredging is cool. People have I've had conversations about the whole, what do you do and what is that, right?
Yep.
Where do you work? I work for a dredging company. What's dredging, right? And those conversations are fun because what we do is cool. Um, me and IT, it's taken us years to get past just regular corporate IT and being able to be more involved on the project side, and we're getting there. A lot of that is due more to the advance of technology than anything else, but we're getting there. And the more that happens, the more opportunities that we have as IT people to get out there. A former IT guy, somebody that's moved on, um, used to call it blue collar IT, right? Because you get out there with the grubby pants, the hard hat, and PPE, and you're in a crawl space, electrical crawl space, or tracing out cable, or mounting antennas and equipment, and it's dirty, grubby work on the water, um, doing some really cool things, right? And it's not your bank IT or office IT sort of thing. It's really getting involved in the dredging side, which is a very, very cool business, and it's fun to tell people about. So um, I totally agree with you. Some of the best memories I have of working with the company are out on the field, either on a dredge or in a project office, get to know people. So
I do a very different job today, Patrick, as you know,
yeah,
but I look for young engineers that this group will all lead to future young engineers. I have many friends that work in engineering. I graduated. I keep in contact with many friends. It's hard to find many of them that had the experience that I was fortunate enough to have traveling all over the United States and the world doing cool projects that you can view from space. And I will ever think that that was one of the best 5 or 6 years to start as an engineer and get your basis on what is engineering.
absolutely.
I have
Adam
one
asked me
more.
a
We have one
question.
more question. I'll answer one more, and then
Then
I
we
and
gotta
then
wrap up.
wrap up. But yeah, do you have one question about programming? You mentioned C++, Python. I dabbed in several languages, but going very serious. I think short answer when you explain those two, those I think Dredging covers. So I say C++ because I'm old. Patrick probably will laugh at that, but because I'm not that old. But C++ was it was C then C++. That was kind of Microsoft's language. Languages today are becoming more generic. I mean, I do VBA, I do Python. I don't do C++ anymore. If I was to recommend a language to learn, I think Python would be my ultimate piece because it's kind of becoming the de facto use all open source program. You know, if you were and Patrick is probably you probably got better answer than me, Patrick, to this. You work in the space. If you were to become a data architect that was working only with, you know, Azure environment tables, maybe there's a different language that you want to learn because of that. But if you want a general rounding in programming that allows you to build cool programs, do stuff, and use it in many different places, I think I would go with Python.
I would agree. I think that there are a lot of open source and a lot of cloud providers. There are a lot of various web software, software as a service, cloud-based apps and whatnot that offer APIs that you can hook into with Python. It's just, and technically it's a scripting language. It's not even really a programming language, so it's a little easier to learn. And it's very broadly utilitarian. So
Yep.
it's a good place.
And if it's set up in the right program with PyCharm, I would use PyCharm is what I use. But if you set up in the right thing, it's very user friendly with color coding, right, Patrick? Color coding, syntax color. It just works really well. And the nice thing about it being open source is for self learning. Google is such a good outlet for open source kind of programs like Python because there's hundreds of people, that probably millions of people using it, filling out blogs and user posts.
Yep.
Sounds good.
I've enjoyed
I've
this as
enjoyed it.
well. We've consumed the hour of your time, and I really, really appreciate you making it available. I appreciate Adam being here and helping to ask good questions. And we will put this on YouTube on the playlist, and the rest of the team, when they're available, will watch as well. Um, Very good educational opportunity. Great questions, great presentation. Very, very much appreciated. Any summing up comments you want to make before we finish?
No, I enjoyed it. I'm happy to do it. I'm happy to do it next year, Patrick, if you want to. And if you have a certain direction you think the presentation go into, I'll improve it for next year. But I'm happy to do it. I think it's important to show things to the next generation. Otherwise, there won't be a next generation of engineers. So it's up to us to mentor them.
Again, very much appreciate your time and the great conversation. And yes, I very much hope we'll do this again. Thank
Yep.
you.
Thank you very much. Talk to you later.